Hello guys, so I'm back with a new tutorial, new circuit and new waveform. So today is we're gonna learn about full wave rectifier. It is a tutorial number 3. To see and understand the basics and introductory part of the LTSPICE, you need to see tutorial 1 and tutorial 2 of the same LTSPICE playlist. So for this, it is required that you know the theory background of the LTSPICE. First of all, I will brief you about what is the functioning of full wave rectifier, and then we will quickly switch to the implementation part on the tool of LTSPICE, and we'll see what are how to generate a waveforms and what does this signifies. So what is a full wave rectifier? It is a full wave rectifier or a bridge rectifier. It is defined that converts the both the half wave of the cycle of an alternating wave or AC signal into a DC signal. So full wave rectifier are used to convert AC voltage to the DC voltage, and that will require four number of more than one number of diode to construct. So the full wave rectifier is a process of converting AC signal to DC output. So you can see here you are having AC signal, and then at both the positive and negative half cycle you're receiving some DC output signal. So how this is happening, that we're gonna see quickly in a while. So this is the thing that that the circuit that converts the alternating AC current into the DC, that is a direct current, that is known as a rectifier. So if such rectifier is working in both the positive and negative half cycle, then it is termed as a full wave rectifier. So hope so that you are familiar now with what does this full wave rectifier means. So it is a diode, it will permit the current in one direction only and blocks the current in the other direction. So let's see what is happening. Coming to the LTSPICE part, that is the most important part because we are learning this tool. So the theme is LTSPICE and learning this tool. So here you need to focus more that how to build a circuit, how to take the components, and then how to see the waveforms. And I already explained you the theory concept that we are converting the AC to the DC. Now we will quickly implement the practical part, that is simulating a circuit on LTSPICE. So let's see how we can build a circuit of full wave rectifier and see the waveforms whether we are receiving it or not. So let's start this. First of all, now you are familiar to start it with a new schematic. Then go to the components. First of all, we need to create one transformer for primary turn and secondary turn. So that will be creating using an inductor. Either you can take it from the component or as well as you can directly take it from here. This is L1 and rotate it. Control R. This is L2. Okay. Escape. Then we need 4 diodes. So we'll take this, rotate this. The direction is very important to create a bridge. We need a 4 diode to create a full wave rectifier, that is either a bridge circuit. The direction should be in this. Its direction should be such, and this should be like that. And then escape. Now first first we will take all the components only. Now when we need a voltage, then escape, and at the output end we will need one resistor, load resistor, then escape, and then connecting this circuit using a wire. So first of all, connecting this through the bridge. Okay, this is fine. Now connecting this inductor with this circuit. So first we'll go at this point, and the second terminal will go at this point. And then here. Now where we need to take the output, this node will be connected at this point. The second node of the resistor will be connected at the other direction, and press then you need to connect this circuit supply voltage. Okay, so for this bridge, creating a bridge circuit, you need to be taken care of that. Okay, something messes out, then there will be a problem. It will show an error. Escape, and then we need a ground. So here we will require one ground, and here we will require a ground. And then escape. Now we will create a connection between this transformer. That for that we will need one mutual induction value. For that we will use dot op spice directive. So L1, L2, I'm taking as 2. Okay, and place it over here. Okay, now the dot is showing the connection between them. Then value of the resistor, let's say I'm taking at it as 2 kilo ohm. Okay, then picking up a diode, pick a new diode. This, now you're familiar, going to the component, right click, and then giving its value or selecting it as per the specification given in the dialog box. So I'm selecting this second one with the average current of 0.20 ampere. So all need to be similar diodes. So then select OK, pick a new diode. This one, okay, and so this is done. Now we need to give a power supply, and what are the values remaining? Okay, values for the inductors are remaining. So for this, maybe I will give 0.5 milli Henry, and for second one I may give 3. Okay, now giving it as a sine pulse will get. Offset is not required, so give it 0. Amplitude I'm giving it as 5, and frequency 20. Okay, and now we will do a transient analysis, simulate it, and in the transient we will give 3, and start external DC supply voltage at 0 voltage, and okay. Voltage V source V1 and inductor L1 are paralleled, making an overdefined circuit matrix. You will need to correct the circuit or add some series resistance. Okay, so for that we will add one series resistance. Go to this trans again, right, by right clicking. Sorry, you need to go at this value. Go to this and right click. The series resistance, maybe I will take a 0.2 milliohm. Okay, now let's see, run it. Okay, this is the script we are getting. First we'll look at into the waveforms. So at the input end, okay, so this is the input end, 0 axis, and the amplitude is 5 to 5 with respect to the time, because we are doing a transient analysis. Let's see what is the output we are getting. So output is need to be taken from this end. Okay, so So we can see that it is a full wave rectifier, that at both the signals we are getting either it is a positive cycle or either it is a negative cycle, we are getting a DC output signal. So this is what is required. So in both the cycle, either in a positive or in a negative, in a forward or backward region, one of the uh, diode always gets on and create a continuous connectivity and gives a output. So this is the final output. You can zoom it in even more, so you can, it is more clear now that what is the output. So the output is amplified, as well as um, it is giving the output at every positive and negative cycle. So now you need to give me a reason in the comment section why and how this amplitude is amplified with respect to the input signal, and let's discuss in the comment section, and I will let you know the answer if you are going incorrect somewhere. Okay, till then try this out on your laptop, and we will be taking some more complex circuit in the next tutorial. Stay connected, stay tuned, and keep learning. Stay safe, guys, and do like, subscribe, and share with your friends. And thank you so much.